Advanced Python organization involves using modules and packages to create scalable applications. Modules allow code reuse, while packages help manage namespaces. The Requirements.txt file is crucial for dependency management, ensuring consistent environments across development and production. Mastering these techniques is essential for efficient professional Python development. Python modules and packages are essential for scalable applications. Modules are single.py files containing reusable code, while packages are directories of modules. Proper organization and namespace management enhance code readability and maintainability, allowing developers to efficiently manage complex projects. A Python module is a single .py file containing reusable code components like functions, classes, and variables. It promotes code reusability by allowing imports into other scripts, reducing redundancy. For instance, Fibo.py provides Fibonacci functions accessible through simple import statements, enhancing efficiency and consistency in Python projects. A Python package is a directory with multiple modules and an init.py file, marking it as a package. It organizes related modules into a hierarchical namespace, preventing naming conflicts. Sub-packages allow deeper structure through nested packages, enhancing modularity. The double_init.py file can be empty or contain initialization code, signaling Python to treat the directory as a package. The math_operations package exemplifies structured code organization. The root package, math_operations, includes an _init_dot_py file. Subpackages, basic and advanced, categorize functions by complexity. Each module file, like add.py or mool.py, implements specific operations, enhancing modularity and logical grouping within the package. Modules and packages streamline code organization by dividing complex systems into logical components, enhancing maintainability and team collaboration. They provide namespace protection, preventing naming conflicts, and promote cross-project reusability, reducing development time while ensuring consistent functionality. These benefits make modules and packages essential for efficient and professional code management. Mastering Python's import system enhances module loading efficiency and namespace management. Absolute imports provide clarity by using the full path from the project root. Relative imports use dot notation for modules within the same package. Selective imports reduce namespace pollution by importing specific names. Avoid wildcard imports to maintain clean, debuggable code. Absolute imports use the full path from the project root, ensuring clarity and explicitness. Relative imports, using dot notation, position modules relative to the current module. Selective imports reduce namespace pollution by importing specific names. Avoid wildcard imports as they clutter the namespace and complicate debugging. Absolute imports are recommended for maintainability. Aliasing allows for concise code by renaming imports, like import numpy as npe. Selective imports, such as from math import sqrt, enhance readability and efficiency. The Requirements.txt file ensures consistent environments by listing dependencies, e.g., numpy == 1.24.3. Use pip install r requirements.txt to install these dependencies efficiently.